Hi, I'm Sai Krishna. So let us look at the question number one. In the question number one, we are told that x and y are independent with uh, density function of x given as u of x unit impulse function x minus 1 minus u of x minus 2, and density function of y as u of y minus u of y minus 1. We are told that z is equals to x plus y. We are told to calculate the value of density function of z. First thing by convolution and the second thing by geometric method. So let us look at the solution for this. So uh, first look at the convolution method. In the convolution method, I've just taken up the values here and then multiplied them, and then so these I've simultaneously multiplied them and applied the integrals individually. So from this step I've applied this because we can change this function to, we can change the integral from minus infinity to infinity to 0 to z minus 1, because there's an unit function alpha minus 1 here, uh, alpha minus 1, which can be changed to 0 to z minus 1. Similarly, we can change the function this as z minus 1 minus 1, which is basically z minus 2 to 0. And then here similarly we have applied the integrals and solved the question. This turns out to be z minus 1 u of z minus 1 minus 2 into z minus 2. I've basically just multiplied them and added them together. So let us look at the how did I do the graph. Here I have done the graph by simply like z minus 1 u of z minus 1, I've just basically drawn line. Similarly, I've drawn x minus 3 u of z minus 3 as a line, and also I've drawn a line z minus 2 u of z minus 2 as an horizontal line here. So I have see I've this line basically these two lines represent z minus 1 u of z minus 1 minus z minus 2 u of z minus 2, because as we are basically subtracting this from this to get this line. Yeah. And then this line is basically this minus this, and then I've basically done the calculation, and then I've got the answer here. That's it. And then coming to the second method, geometric method. In the geometric method, we are given that z as x plus y, and I've assumed density function of x as u of x minus u of x minus 1, and density function of y as u of y minus u of y minus 1, simply because it becomes easier for us to calculate by considering these values, and later we can shift it rightwards by 1 to get the required answer. So I'm basically considering here, because here in this case there is only 0 1 1 to 2 and greater than 2. I've assumed here three intervals, which is z less than or equal to 1, z between x 1 and 2, and z greater than 2. Okay, for z less than or equal to 1, I've drawn the triangle x plus y less than z, x plus y equal to z, and I've calculated the density function of z as basically the probability that the random variable z is less than or equal to the small z, and then I've calculated the distribution function first and then the density function later. Similarly, I've calculated it between z ranging between 1 and 2, and for the value z greater than 2, the density, the distribution function is 1 because it is uniform, and then the density function is 0 because it is a differential of the distribution function. So I've drawn the graph, and I've told we have discussed before that we are not given these values. We have to shift it rightwards by 1, because we are given u of x minus 1 and u of x minus 2 here. So we have to shift it rightward to get the required answer, which we'll get. In this way I've solved the question number 1. Thank you.